see there are two fundamental ways with the data it is representing and going to the collection of your data. It is a discrete object and a field. The discrete object view which represents the objects what we have seen on the field, and those are present on a surface, and it is represented to the real world. So here the field object we can see into the points on your map, and we see in the form of a lines and as well as in form of polygons. So here on a surface, these few layers we can see in a field. It is represented to real world as a finite numbers of variables. It's a portion of different variable, and it has a number of numbers, and there is different types of number of variables we can see. Yeah, each object and each number which can define, it has a definitely own position on a surface. So the data models also we can see whether the data it is belong to the raster data or vector data. Here the first you see in previous picture this whatever it is indicating. We see here there are some uh, lines are there. The lines it's having making is a grid. Those are vertical lines, horizontal lines, whatever what we have seen on this picture. This you can see here. It is showing the grid formation actually. These are all it's showing as a grid formation. So the raster data, whether we can see in a raster data, the entire map it is divided into the small grids. Those grids we can see into the like a small cells or tiny cells also we will call. Here it has some value. Every grid or every cell it has some value. It is representing to store data. The data it is again representing with that nature of object to whatever it is going to making, and it is corresponding with the specific location on a specific ground. So here the raster data we may think actually it is a matrix of values. Different matrix are there or different values which are having. So here the major now what we are collecting the data you should converting and involving the data into the computerization mode. So first step what we will do, whatever data we will connecting or we are collecting from the fields or a source, the data you should be converting into a digitalization, or it can be ready in your computer to change or to digitalization model. So how it will be changes means that it will be consisting of a different number of series. Now you can store into the that is in a binary method or convert into the bits or digitalization. Now it is the data it is uh, making of, and with this represent xy coordinates. So here two-dimensional data what we have collected or what we have modified from hard copy to the soft copies, those data you can see into the uh, digitalization mode. The digital satellite imagery or aerial photographs or ortho photographs or whatever it is that those pictures those pictures we should converting into the once in a digitalization that will be converting into as a grid format. So the data you can call that is as a raster data. So sometimes maybe we see the data we cannot see in a grid mode. But here we can see in okay, let me finish about the grids. And the grids we see in each it has each cell. Those cells are called known as the pixels, and it is showing this. You see here points maybe in the point same point you can see here in a raster data. You see it is making of grid. So group of points or a group of grids it is making. You see here it's making of a line in raster data. So later the polygon it is going to be created and it's consisting of number of a grids. It is consisting of a number of a grids. So the data you can converting into the grids level or grids into the grids format. So there is a grid format. It has a cell or we'll call the cell it is a photo uh, electric energy cell. It is known as a pixel. So now it is a confirmed. We see here the raster data. It is you can see it is in a pixels also. So there is a group of pixels. It is a leads to formation of the object. Every pixel it has a own location and it has own coordinate also, and it has a number in a digitalization model. The number it is known as a digital number. It is known as a digital number. Now coming to the vector model type. In a vector data model, you whatever recorded data we have, it has a definite shape, and it has a definite shape, and we can define by these numeric values, and it is making it XY coordination style or XY coordination coordinate be there. So if suppose if you wanted it's a point, the point is a pair of a coordinates. You can see here, you can see here it is big side, and this it's making of a right grid between that grid points are arranged. So here the grids how we can make it based on the lines only. So that lines it is the XY coordinate, x and y axis. So that having again the number. So here these coordinates which are also having the numbers. Also having numbers. So that is the real point. Uh, point. The point is also the sequence. It's making of XY coordinates. So what about points? It's joining to the sequential points. They will continue. The points will be forming. So that the the continuous. You see here it is showing the line. The continuous group of points are making to a line. So that it's also having the same coordinate system. So that we can draw. This is the we can draw. This is we can divide into small parts, and we will get a small points. So that the point which are joining to the one to another, one to another, one to another, and it is leads to formation of a single line. Yeah, and finally, uh, these n number of lines which will be formed continuously from first to the last point, and maybe sometimes it is a join and completely it doesn't have a uh, the enclosures, or whereas sometimes maybe if it doesn't have enclosing. So here in a vector data, the position and the shape, that's also playing the very important role of any object. So that here the position, whatever position it has, and definitely it should be having a shape also. So that these points are continuously with the closing, with closing of those lines, and those will be leads to formation of a polygon. So here the main thing it is in a point source. In a point it is also made up of a xy coordinates and different points which is leads to formation of a lines and the closer lines wherever we can see. This is, you see here, this is in a polygon, this is the top one, this is the one line, and this is the side one, you see here, this is the one line, and it will be joined here, and next line again it is joining here, and next line again it is joining here. So that it is a made up of, it is a making one closer object. This closer object it is indicating, the closer object it is indicating as a polygon. So this is the polygon. You see here, this is a polygon. It is known as the same polygon. You can see into the next picture of a raster data here. In a raster, it is divided. It's made up of a cells, are made up of a different cells, and it is leads to formation grid or a box, whatever it is that. So we can say the number of polygons. It's a number of polygons. It have the clear information and the features, whatever features we have seen. Yeah, the vector map or vector, it is also having the information. It has some information. The depend on that shape, and it can be explained with using of different shape files, and it is useful for to storing the data in your GIS files. So there are various types of vector models we can use, particularly in a topographical model, vector chain model, and spaghetti model. This detailed explanation of the models we can see, but actually in our study point of view, only just basics are required to us. So here in vector data structure, you see the in a vector data structure are raster data also. These two are a common method, are common. These two methods are very commonly we are using in the presence of representing geographical data in particular tool of a GIS. Both represent a different way to encode and generalize the geographical phenomena what we have collected from a field. Yeah, both can be used to code both fields and both discrete objects. Yeah, in practice, a strong association between raster and fields and vector and the discrete objects. So here you see here the vector data types. Vector data types, it is a line, and the lines will be closing its least formation of polygons. So here in a, it is covering to study. It is covering. We will study in a arc info map, which is covered. And the arc info coverage or arc info map, it is software. It is that old version in a JS. The table systems to establish a relationship between the spatial information to the and attribute created there. So it's giving the information between the two What is that spatial information, and the second one is the attributes. Second, next time, shape file, the making of a shape file. It is very common and most important. The data, whatever data we collected from the field, we can save it shape file in a ArcGIS. Third one, it is a geodatabase. The geodatabase, the next generation of ArcGIS data. The next generation of ArcGIS data, which provides the relational power of the coverage with the usage of using the shapefile. So the based on that shapefile, what we have created, it is very useful for the creation of a database. According to that, we will create. Fourth one, uh, digital line graph. These file format we can see in a vector data where it is replaced into the standard digitalization model of a data. It leads to formation of spatial data transformed into the standardization. So the data, whatever we are creating, we should converting into this spatial data standard formation. So later, one more file will be also creating here. That is a topographically integrated geographic encoding and referencing. It is called as a tiger. These files are having geographical features like a roads, man-made features like a roads, uh, railway lines, or rivers, lakes, political boundaries, census, and other information, statistical information, census statistical information we see. So that here, the vector data type we see here, it is in a, maybe it is the data, it is in a point information or line information, or maybe it is stored into the polygon information. So the same you can see here we in a the raster data which contains the special fields. We can see it is in a grid format or a cell. A small cell will be found. So the numerical representation of a say spatial surface, suppose. So you see, this is actually the terrain, whatever surface or a terrain you can see, it has elevations. It has elevations. This one and this one you see here, these are the elevations. Those you see here, these elevations. The elevations, again, it has a numbers. It has one number, and this line is also continuously, you see, up lines here, down undulations. These undulations, these undulations will create a making a line. So here the lines, the continuous lines you see here, the continuous dotted lines are there. Each one it has a number. It has a number. So these are the points. The contour how it is going to make in this one. Here it is again the point size, the points, and its connection to the one to another is making it to the a line. And here this is a grid style, and you see down contour and it has a flow line. There are six approximate representations of a field we used in GIS. Your first one you see regularly spaced sample points will be seen. The points whatever showing systematically, the points were arranged. In a B picture, you can see here it is irregular formation and irregular space was maintained. Yeah, in the third picture, uh, you see here the third picture, it has a rectangular cells. So the line it is making systematically, and the vertical and horizontal lines were making here, and each horizontal and vertical line it is a making of one cells or grid. And later in a next picture, D you can see here a irregularly polygon shaped. These shapes you can see here, those are you're unable to get a perfect shape. The polygons what we have seen here. And in next picture, it is a triangulation. There is a triangulation method. In a triangulation method, the lines were joined irregularly, and it is made triangular irregular network. Next picture and the last one, polylines are it is leads to formation of a contours. So there are various types of formations are there where we can see in a vector data, and as well as the grids also which is representing, it is maintaining the specific shape as a matrix of different square shaped grid size or grids will be forming, and each grid you can see like it has a number. The number it is indicating the cell. So the number it is useful for to the geographical to making of a geographical attribute, like it is you can see we'll consider that is as a unit of a space. Yeah, whatever data previous that what we have seen in grid data structure, the grid size is defined by extent, spacing, and no data value. It has information, number of rows and the columns, cell sizes. The cell sizes are having the x and y coordinates, top, left, bottom, and right coordinates. So suppose if it has the grid, and here one coordinate, I mean coordinates means latitude and longitude. The latitude and the longitude. So it's a making of a different cells and grid sizes also. So the grid value it has the grid value. Each one grid it has a value, and the real floating decimal point and the integer value maybe it have associated with the attribute table. So what is the grid? Now we can define the grid here. The grid it has a cell look like as a cell, and it's also having the x and uh, uh, coordinates, and number of rows and the number of columns which are making to formation of grid. The points may be converting into the cells or grids. Yes, definitely. Actually, I told you in just now. Each point, whatever you can see, it is a making of a grid. And group of points or group of points which is leads to for making of a line. lines same, the lines also made of a uh, polygons. So here the best example for this one, points which are converting into the cells. Just you can see each cell it has a uh, point. The line sequential also, the line sequence also. Oh, you see here in the first picture, the left side here it is showing the point formation, the continuous point formation, the continuous point formation. It is leads to formation of a, it is forming a line. Similarly, in second picture, the right side also you see here continuous grid lines are there. The same similar structure we see here. The lines are pixels. It has a pixels also. The cells it has a pixels, and continuously those will be forming a line. Continuously the line will form. A polygon as a zone of a cell. It's definitely the polygon itself. It has a group of a cells. How they will form? The lines have sequence of a cell. Yes, the lines whatever which are formed in it, it is forming in a continuously group of a points are making into the line. Same. The polygon it has a number of points on the lines. The closed lines it is showing as a polygon. So the polygon it is indicating the outer structure, the external structure or external layer, whatever what we are seeing here. These dotted or pointed, continuous pointed lines, it is a closed, and showing the outer structure. The external structure it will be outer layer it is showing. So that if it is a field, you can see if it is a field. So here in grid cells also we see in your raster data, and it's made up of a group of a grids. The same structure we can see here. We can see it the same structure, and it is filling the grids are a cells. Yeah, the no data cells means here the beside and they see here the side of a polygon cell. This the polygon cell additionally which are having, but there is no data in that. Empty. It doesn't have a data there, so that we can show those cells into the empty. What's what is differentiation between the what is the differentiation between the raster data and vector data? The both data types which are useful for making of or updating the things in different aspects which are using the characteristics sometimes we may see in a generalization, or sometimes we see, sometimes we may see in a broad concept, or sometimes we see in a narrow concept. So how they are giving the relation to shift to the whatever data in previously what we have collected. In a vector data, it is a relatively low data volumes, faster display, and which can also store the attributes. Less placing to the eye does not dictate how features should be look into the GIS. Whereas in a raster data, it has a low data volume set it has, but whereas you can see in a raster data, it has a high data volume. There are no attributes information. The high inherent store how features should look into the GIS. Yeah, there is a differentiation between two. One, it is a making because of one, it is a the raster data. It is a making of a grids and the cells, and a vector data. It is a making of a point by point, and it is forming of a line. The group of a lines or closed lines we can see as a in the form of a vectors or polygons we can. So there is a comparison between the two, whether it is belongs, whether these two are in a raster and a vector. So in a raster, we can see the outlines and but not clear, not a clear. But whereas, clear means here detailed. The detail we are unable to study in a vector, or whether you can see in a raster data. The raster data grid-wise it is going to be making so that each grid we can see zoom in, and then the pixel sizes also we are able to find out according to that we see very detailedly in a raster data. So what is the source for this one? Okay, before completion of that one, again once we need to discuss this. Yeah, the cell network, suppose if it is a drainage pattern what we have seen on a hard copy, you have drawn like this. You have drawn like this. So what is happening here? Group of lines, and the making is a stream. The streams and the streams. The streams were one to another streams were joined here, and it is if you can see very detailedly, the it is showing as a in the form of a small points. The points which are bring and joined to the one to another, and this is the uh, further. It is a forming of the poly lines. In the same, you can represent on grid cells. In a network cells. The network cells, yeah, the network cells, the continuous the line format it is there according to what we have seen on a map, like in the form of a polyline. Same the polyline also here it is making as into the form of a grid. So how many grids it has taken? Here are two grids it requiring, and here three grids, and here four grids. So that it is a given it has given number also you see. The first it was started from here, and later the another stream was joined, but that it is only the red point it is indicating the joining point, and later the third 1 plus 2 it is indicating as a third, and then the 3 plus 2 the another grids are making with the same continuous line. Next the another grids are joining here. There are Now you can give number to this 4, and the other side of a stream, it is indicating is 5 number, and later join this one, the 6 was started. So this is, so the cell network, it will be like that. Here grid zones. See the variation of grid zones here. That is a depend on availability of a data. We will dividing the grids. Floating point of a grids. The continuous data surfaces using the floating point are decimal numbers. These are the floating points, and with color, the color it's showing. The color it is showing here. Yeah. Next, the same. The value attribute table, now you corresponding with the attribute table. Now you coordinate with that attribute table with integer of data, grid data. The value we should count. You see here the first number, we should count only the numbers. The numbers, how many are there of a first numbers? 1, 2, 3, 4. 1, 2, 3. Almost 12 numbers are there here. Same the object, how many grids it is going to be formed. That's we have to calculate. Next. Uh, Again here also having the 6 ones, the value of a grid, first number of grids, it has a 6. Yeah, second 24, 23 oak type. These are all the tree type material or vegetation plants, how much area it was covered or how many plants are there. According to that, the occupation of uh, plants or vegetation zone to convert into the grid system, we will give a number for each individual type of a plant. So these are the attribute type. Attribution means here creating a table according as per our data. Yeah, rastering the sample. The raster sampling, you see here the values are averages for cells. We see here uh, all the cells, the average we can calculate, and maybe depend on their size and the value. It is covering some grids. So according to that, the arrangement of a grids, we will calculate the average value. So the raster generalization here. The general point rule we see here. The only 3 points, three grids were occupied here. This is the central point of a grid, this one, and this is the sharing of a data in the form of a grids. So here the rough calculation, cell by cell evaluation, it is required for like a mathematical function. The best example for this one, precipitation. The precipitation minus the losses. The losses maybe we see it is evaporation. So the first it is indicating the precipitated area, and later it has evaporation or infiltration, both were there. The both we can see. Yeah. These are the cells. It is yeah, uh, showing the precipitation of area and the losses evaporation by evaporation or maybe infiltration, and finally we will get some value from this one. So from that value, the runoff will be there on a surface. So the runoff generation process, you see the infiltration excess on a land, which can be flow on a surface, and it will be stored here through this one. And the partial area infiltration, excess overflow, whatever we have, it will be seen here. And slowly after once, if it will be, it will getting the saturated, and after completion of those infiltration of a force, and later it will be runoff will be started on a surface. So these are all the point line to line. It is showing. It's a line to line. It is polygon method. It's showing in a polygon method. The runoff generation at a point depends on rainfall intensity or amount or anti-descent conditions or soil vegetation also is depend on the scale. Depth to water table depend on the topographical features or topography, and time the scale of interest. So cell-based discharge, mapping flow accumulation of generator runoff. You see here different layers are there, different layers are created. The precipitation zone it is showing, but later finally that is not our intention. We'll see the form of precipitation in the maps. You can see here it is the grids you see here, the runoff you can see in a grids. And the accumulation of a runoff we can see in within a watershed. There are contour lines are there. The contours are showing this one. Uh, these are the analysis of cells. Mm, the cells which are the grid cells which are occupied by the object formation. So we are we are reprojectioning the targets. The cells were filled by the target means here objects. The objects which are forming how much area it was formed or how much area it has taken on cells. Those cells it should be analysis. Spatial snow melt of raster. This is so yeah, depend on the temperature index. One day, I mean, the first day what it is the snow fall, the initial snow depth we can calculate and temperature also. The temperature also. Yeah, the first initial stage is showing the 42, 42 and 40 grids and 40 grids which is occupying the depth. And later it is maybe 100 meters of depth each one having. And the on their temperature, the next step maybe if it is increasing. So what will be happen? That it is showing there. Yeah, we will calculate that whether it is a temperature on 150 meters. Uh, the temperature maybe if it is increased, the calculation will be there. According to that, the map will be created. So these are all known for you. Only just what we have learned till based on that grids. We have seen that the spatial analysis automatically we will use nearest neighbor sampling. So according to that, we'll once if you get a data, now we will update based on the based on the data what we have collected the previous. Those will be used as a reference or whatever it is that. So according to that, we will uh, change. We'll extend we'll change the scale type or we'll extend the cell sizes. So this is one thing. So what are the sources for GIS data? That's also important to us. The sources of data, it's depend on two types. One, it is the spatial data, and second one, it is the attribute data. The data input process, it is the operation and encoding the two types of a data in GIS data formats. The creation of a clean digital database, it is the most important and the time consuming depend on their our task and what we the data it is going to for which purpose that is and another one it is we need to establishment of a particular area of a data. The data it should be in our hand. So here the data maybe it is availability in a different format. Maybe it is in a hard copies or aerial photographs, remotely sensed images, or point data samples from survey what we are carried out, and existing digital data files. These digital data generated from different sources. So there are at least four basic procedures it is required. The first one it is we'll do the manual digitizing. Second one it is scanning will do automatic scanning. Third one is a entry of a coordinates with using of a coordinate geometry. Fourth one is a conversion of existing digital data. We can convert whatever existing data we have. So here the data I should converting into the raster data to the vector data. The raster data, you can scan the data, whatever data we will get in the form of images, in different formats. We will convert into that in a raster format. Maybe the scan data, sorry, what we are collecting the data, we can see it is in a raster data. So now we can converting into the vector data. So there we can use the GIS software packages and the data, the formation of information data, you can see it is in different formats. So that the GIS is going to be supported to which format, and which will convert the data into the whatever we have. So you should converting into that. So that's one thing. So here finally, in a GIS software package, we can convert this raster data into the vectors. Uh, Here the entry of attribute data also. Here the attribute data, you can see it is in a table format. We see that is in a table format. Um, Table format spatial. These are all the spatially what we can see. I show you that is also yeah, no, not this one. Yeah, it's a good description. No, it is not there maybe. Okay, anyway, the data it should be converting into the table form. The additional data what we are creating, you joining the data into the table. So which contains the new attributes to existing data already in a GIS. So that we join with that one, and together we common field most should be present, and most GIS software can then use the resulting table to display the new attributes into the entities. So we have many sources to building the data. Particular database creation, the GIS attribute data we should use. The data we should converting into the table model. So here it is showing, you see here a polygon interpolation. Every polygon you can see here, you check it. The polygons, it's showing the polygons of different colors also. So every point means it is a location, it is showing the specific location. As well as we're showing in different colors also. That's also we need to find out. You see here it is in a contour model. This is a polygon. We can see here the spline model of a contour model. This is indicating only the area of the average data it will be calculated, and the area according to that area or according to some range of samples may be fall or covered within this location or within this category. A spatial surface used it is drainage pattern. These are all the drainage patterns what we have seen ground surface point of view. It is showing different elevations are having a different heights, so that automatically it is showing the different uh, terrains. So here you see the top, just you can see top position, the formation you see here, just it is in showing it off. So between to this one, the valley is formed. The higher, the rough area and higher area, it is showing the hill. And between this, the small streams also we can see here. It The small scratches, the lines, patterns of lines are showing the stream, so that finally we will confirm yes, this is a hilly area. There is a differentiation. You see, it is a 3D picture. Uh, has taken in a LiDAR format, LiDAR, but whereas we can see the same into the JS also. So topographic features which are showing the hill areas. This is a valley contour. It is showing whatever it is that this is a hill. It is hill the side. It is creating the valley towards hillside. This is a hill. It is going to form hill towards from west to east. Yeah, this is useful for to find out the downslope direction. Okay, no need, as per syllabus, it is not there. Okay, yeah. Wait, I'll show you one more PPT. Yeah, the maps and the data entry, how we will do that. The uh, data types and the data editing and the quality. Here, the data always we will get it into that. The data what we are collecting or what we have collected from the field, we should convert into the GIS map, the spatial data or whatever it is that. So here in a GIS map, the GIS map concepts, all the features it should be covering the in a map in a different types, the map features, map information, map projection, and map systems, and different types are there. Oh, wait. See, okay. The map in a map content we see here the basic concepts are required for different map types or map elements also we need to study, and it has map information and map information. The map it's giving the man-made things or whatever arranged on the surface, and as well as the morphological features of a naturally arranged things or naturally arranged of objects, whatever formed on a surface, those will be also captured by that one. So later we will divided into the availability of a features on a map. According to that, we will divide. So here, first we see the map types. The map types, the GIS, whenever it was started with using of world maps. First of all, what it is that a map? That's also we have to know. A map, it is a very simplified visual representation of a real-time things on a surface what we have identified. So here maps which can be a model, the world into the more than one way. So we see that maps, whether it is belongs uh, to the topographical features and the contours and yeah, formation of the different objects, and we are called that is known as a chlorophyll. And later we will compare with ground features. This the uh, topographic maps. You see here, these are different types of maps are there. So that now we can divide into that. The source is also very important. Once it drawn on a map and it has a name, the title it is also it's required. The source, what is the source for this one, we should correct that. And later, the what are the features we have identified have to show uh, on a map in the form of a legend. In the form of a legend. So that's these are the features must it has on a map. In the image, we'll discuss later about the image also. Once the image, okay. Before we will download that map into the GIS, GIS or GIS. Once if you can download that, it will be showing into the this part. I see the arc map is that. The features are there. We can use with these features and whatever you require or edit, whatever you add or delete, we can do here. So here topographical maps and chlorophyll maps or density and maybe contour maps. We can see that is known as a isoplete. The types of a map. In a topographical features, what are the topographical features we have seen? The map it is showing physical surface features. For example, that roads, rivers, buildings, networks, morphological features, maybe arrangement of hills. These will see. In a contour map, it is showing the lines. It is connecting the point locations. The lines it is which are having the values, equal values. So the same values we can see representing at the height of the hills, and this height of the hills we can measure above the sea level, above the mean sea level, and the isobars also. It is showing the isobars values also, which is showing. And one more, it is the chlorophyll maps. It is depicting the quantitative information of areas. Yeah, the map it is showing the characterized some general common features, maybe pictorial information or seasonally agricultural information. So in rainy seasons, what will be happen? In a rainy seasons, means, maybe you can see one in August and September areas, once the crop areas, if you are taking the photographs in a large scale level. If you are taking the photographs, I mean large scale, large areas covered. So that we will see that group of colors we can see on the image. On an image. So those image convert into the digitalization and you make a map and you divide that whether that area it is belongs to the agriculture area or vegetation means forest zone area. So these pictorial type of information it is giving on a chlorophyll. So one more it is a dot density also the maps which are having the depict by the quantitative information the dots we can it is showing. So different features are there. We map features we will see. The map features, whatever features, if you are taking the photograph and what we are identifying on a uh, topo sheet, whether it's a streets or maybe rail network or maybe it is a water bodies, we can show it is a different polygon. So these features we can classify. We can classify depending on their shapes and symbols we will use, and according to that we will classify them. Example for point classification. The point we see it is like the pointed areas. It is indicating the schools or churches, bus shelters or churches. These the points which are showing. Line features. The line feature maybe if it is in a yellow line present, maybe on yellow, or sometimes maybe you can see the line double lines are there. The double lines and the in a modern map the double lines and uh, showing in a red color it is indicating as highways. So the lines you will be find the that. And polygon shapes, these are polygon shapes. Maybe if it is a blue color of a polygon, the polygon, it should be closed line. So it is filled by the blue color example. And so it is showing the water body. Another feature, it is for text. For example, the text, we can write it is that it is name. So we should write, maybe it is a building or what, building. Or sometimes maybe you should write their point also. Go, let's mask you. Or sometimes we can show the information in a text, roads, like that. The poem, that is a text feature. So another one, it is information. Okay, yeah. Uh, information. The information, it has some guidelines. It is giving the guidelines to us for information that the map, it is a translation where from a digital hard copy into the digitalization form. So in the GIS, in a GIS, we can store into the spatial information, uh, and once it will be converting into the it has a geometric codes, and it has a, geometrical information there in a non-spatial object information will be also there. It is, you can see in the form of attributes. So here the geometry, it is indicating the particular shape and the particular location of key objects. The attributes, the descriptive information known about the objects, normally displayed on a map through symbology and annotation. These two will be also symbols. Symbols on a map. The symbols on a map, some circles are most common symbol used due to the easy with which they are interpreted. All the symbols should generally be the same color. Yeah, the differences between the largest and the smallest symbols should be great enough to show the differences in your data values. The largest symbol should not be overlapped so much that they obscure the pattern on a map. Yeah, here dots, you can see some of the large symbols are overlapped on the smallest one. So proportional symbols and graduated symbols, these two we need to identify, and we will give the size of a point symbol. It is based on which class of the feature, and it has some value. The value which it is a far between the two numbers. Yeah, dot density maps. Here the dot density maps which are used do not uh, marking, and here the dot density maps use a dot to indicate one or more occurrences of a phenomena. The density is depend on the density of dots will calculate. Okay, what are the advantages of this? The advantages of dot density maps easily to understood by the reader who are there, and easily to illustrate the spatial density. Sometimes the original data can be recovered from the map if the dots are represented at actual locations or phenomena. So one more thing, it is map projection also. Okay, later I'll tell you isoplate map or contours. Here the map projection in compilation of a data based on the GIS data source, we calculate the coordinates and we will arrange the coordinates systematically in the process of geo-rectification and geo-registration depend on their or availability of a source in a JS. The projection it is a translation of a spherical coordinates onto the planar surface, while the datum it is ellipsoid, or sometimes maybe the data we can see in the form of equations. So once the coordinate system, if you can apply or if you can project it on your map, the four coordinates we will fix based on the XY coordinate pairs, coordinate pairs, and the objects what we are identifying with using of this one based on the latitude and the longitude. So here the map projection it will be speaking about that the rectifying the data. Rectifying the data you have to fix particular coordinates um, based on the availability of a source. Yeah, another one is isoplate maps. Here it is showing the equal interval lines and the line will be joined to the one to another. It has a equal value. Just you can see it in this map. It is showing that the contour line it has a 60. Continuously it is go on a 16 only. The color it is indicating in a green color. Okay, next come down into this one. 65. This line it is indicating a so that the value it is going to be increasing towards closed line circle. So automatically changes. Whereas you can see here, here 45 or 50 or 60 the lines are there. You see there are there is a five uh, contour interval differences 45, 50 and 55, 60, 65. The color variations also we can see here. That means to, you see the color it is indicating the blue. Maybe the lowest value means it's going to be down. So it is maybe based, it is useful for storing of a water body or whatever it is that. Maybe blue indicating water now, so that is a reason we are calling it is indicating water body. Whenever covering 60, 45, 50, 60 and 65, you can see 65, 7. From 70 onwards, the color, almost the color we can see from orange and orange 75 till 75 thick orange and later it will be converting into red and red. It is a red zone. So the highest value it is a red zone. The 90 it is showing the highest value of a red zone and continuously you see here some indications dotted lines also we see between the 90 and 100 maybe it is 100 feet. So this line it is completely indicating the 90 here. The ISO means equal lines are joining or equal points are joining in a particular area. So the line it is known as a ISO line. It has a color variation. We can see a color variations here. According to that color variations, we will define the objects. Your statistical analysis later. Yeah, map scales also sometimes map scales also playing a very important role. I'll show you that. Okay. Mm. Yeah, now you see here the right side of something. So now you see here the right side of a map is showing the some values. Refer to this map as a scale as 1 is to 50,000. I told you in a class so many times the map scales. What is a scale first of all? This scale, it is a measurement and it has a particular value between the two dimensions or between the two objects, and it is represented to the on a real world. Just example for here, three types of scales what we have discussed in a practical class there. We know that one, it is a large scale map, second one is a medium scale, third one it is a small scale maps. So here, 1 is to 50,000 it is mentioned here. 1 is to 50,000. So in this case, 1 is to 50,000 means 1 is to 50,000 means it is a medium scale. In a medium scale of a map, we'll get the features. Example for 1 centimeter, if you are measuring on a map, that is showing on a ground 500 meters. Because of centimeters, we are speaking about the centimeters. So the centimeters of a scale we can convert into the meters. So according to that, we will get the correct exact location of object on the ground. The features, what about the features, map features? Suppose if you are going from here, meter maybe 1 centimeter. So now on the ground, you see that is indicating as 500 meters. So the area is covered very, medium. So medium features are covered there. And whereas in second thing, sometimes the scale maybe it is a 1 is to 1000. 1 is to 1000 means you can imagine. You can imagine just 1 centimeter if you can measure on a map. It is indicating the 1000 meters, 1000 meters almost. We see it is a covered more area and more features will be covered. Sometimes maybe you can see in a small scale maps like Indian or world map. We see that is 1 is to 250 lakh thousands. Sorry, 2 lakh 50,000. So it is indicating 1 centimeter is equal to 2.5 kilometers on a ground. So we see what it is a definition here. It is covering a large area, 1 centimeter maybe if it is from here to here. And ground you can check out that almost 2.5 kilometers it will be covering. So it's covering large area, but we didn't get information, detailed information. So here finally, according to that map scales which depicts on a uh, map in the GIS. So according to that, we will fix the scale onto the real world, identifying features whether those features are going to be covered or not. Because of latter ones, if you can download the map and you fix the scale and you have to do the referencing and rectification. Now you can start the editing. Depend on that our requirement. So the scale it is also playing the very important role in all the aspects. So scale up capture that's also important to us. So before going to editing the data, we will before going to editing the data, we'll confirm that area or that area it is rectified by the geo coordinates or data whatever it is that we see. Yeah, here given map scales, different scales are there. Here types of maps where we are going to be generalized. It's ground truth data. Sometimes individual maps also we can see, individual features also we see. So now we will convert into the group. So in a individual data we see here roads and these are all individual objects are there. Once if you can that data and it will become as a group with reference to the scale scale whatever required data we should the offset and later and those I mean those the data if it is not useful to us you erase it and you omit it that so the fact whatever fact we are going to identify on the surface those will be clarified and we should edit and later you can categorize it, depend on the available data what we have identified on a surface. Yeah, every app it has a boundaries. Yeah, in hard copy itself, we can see the hard copy that has edges, discontinues, or sometimes maybe it is cutting of edges. Those we need identify. Most digital maps which are have been distilled from hard copy only, so that we check out whether the boundaries are discontinued or continuous lines. So those according to that we will draw or we will edit. The spatial data input from the hard copy source, everything it is depend on their hard copy sources only. So whether you are going to be digitalizing manually or automatic digitizing, or maybe you can scan. The scan it is you do the automatic scanning or different by the different plotters or different scanners, and the format it should be you can convert. So data encoding it is a must. So before going to editing of a data, the data it should be encoded. So data it should be encoded depend on their data sources, different formats we have, and the formats which are useful for to storing of a data according to the JS. It is a useful for which type of a data stored or which type of format it is suitable for JS. Other than that, we will get sometime errors also. So that the errors we can rectify. Okay, different sources are there. The data what we are getting from the different source from the satellite data, you convert into the maps, and later you convert into again a digitalization model. The digitalization data you should convert into the attribute type means table type formats. The table type of formats and all together. Uh, Again, it's related to the data captured. You can start the editing. Again, we have a reproduction. There are types of errors will be also created while we are enter the data, or once if it is enter the to the data, it is creating so many errors. We will all remove those errors, and finally we will get one output. So according to that, you will create a layers here. You will create a layers. How it is that? Your tablet formation of a data, it's two types we can say. One, it is a attribute show data. Second one, it is the spatial data. The spatial data depend on the coordinates, XY coordinates we have. The XY coordinates means latitude and the longitude formation. The data, it should be format. It has a XY coordinate format, and what we have collected the data you export into the formation of a save files. Later on, it is geocoded also. The geocoding data it should be converting into the address where it is uh, available that object. It should be referenced with that, and we will save into that. So you see here it is a geocoding data. The geocoding uh, data it has a process. The geocoding is the process finding the associated geographic coordinates that should be a latitude and longitude. I hope you have seen in a practical class that rectification and geo depend on the georeferencing and registration. Registration. The map it should be registration based on the uh, geographic coordinates. The XY coordinates are latitude and the longitude. The four sides of coordinates will be created or depend on their um, what you have collected from the field, and those coordinates you have to enter, and it will be creating the base map. So the base map it has all the features. Now what you are going to update in the things within that, it is creating the one grid. Once if you are creating the base map, so that within that grid what you wanted, you do the process. Yeah, applications of geocoding. Yeah, in applications of a geocoding, will nowadays will depend. We see have seen with using of a Google location. You know that the Google location it is depend on the geocodes only, latitude and longitude method. Manual digitalization. Now we are not following the manual digitalization. Only we are following the map digitalization. Uh, we see here it is on-screen digitizing is going on here. Once the data you should converting into the digitalization mode, we will use with the uh, we'll use it a mouse, but the picture it is showing as a manual manual digitalization. Inside it has a small pencil type points will be there. and those pencil type points will be we will draw on a sheet, and we'll keep on a trace paper. We know that what we have done in a remote sensing with using of a with using of a trace paper. You keep on a uh, hard copy of a map, and just you can wherever you wanted to update the things, and just you can select that area. You can draw that, and you give some indications or colors and symbols, whatever it is that. Okay, this is the distribution and precisely identify the set of control points. We will give in numbers. Almost all it is looking into the based on the number model. Controlling points, it has a numbers what you have drawn or edited. The things which are having the numbers in a polygons. You see, all these are polygons only. All these are the polygons. The lines, everything it is closed. Everything it is called, and it is given a number. Control numbers or control points are given here. Okay, now it is giving the ID, that is information. Mm, the first point example for here is showing the ID first point. The ID, it is indicating the x and coordinates. X and coordinates. It has a value. It has a value. We should convert it into the digitalization mode. It is a binary method. According to the binary method, it has a numbers. Okay. The numbers later, once if you downloaded it into the system, it is giving the point wise, and the points are joined, one point to another, one point to another points, which are joining, and it is creating a shape. Maybe it is a stream mode point of view. It is a stream model or a stream mode showing. Here another map, it is a cartographic maps. Here you see here the different contours are there. Now onwards it started the complete map. You can convert into this slide. You download into your PC with use in your GIS software. Now uh, coordinates will be applied. The four sides of the coordinates will be applied. Now at the map it is registered. Now you can start the editing. Okay, now I'm stopping here. We'll continue in the next class. Editing.